So we've just graphed this rational function by hand, but let's take a look at some things that we could see using the calculator if we were to use that. So I've entered this in. Notice I've used parentheses around my denominator, which is very important for these rational functions. We could also use them around the numerator. However, with one term that won't matter. But if you're ever in doubt, use parentheses. It's not going to be wrong if you use more parentheses. So let's go ahead and graph this one and notice some things about the graph. It appears very similar to what we graphed by hand. However, notice what's missing from this graph are the asymptotes. The newer calculators do not draw in the asymptotes for you because remember, they're not really part of the graph, even though to me, the asymptotes are more important than the graph itself. Some of the older calculators, if you're using one at home, may have drawn in one of those asymptotes, and it's just because it's an older calculator and it used to draw them in, but it doesn't anymore. So we can kind of estimate where that asymptote is located, the horizontal and vertical. However, one way to be a little more accurate is to look at your table. So let's do that. Hit second and graph to look at your table. So here's a bunch of points. If you did need to be more accurate, you could plot some of these points. One thing I want to point out, though, is there is one x value in the table that should have an error in the y column, and that, hopefully you know, is -2. You can't plug in -2 for x. So if we scroll up and look in our table, sure enough, there it is. So there's one way to find vertical asymptotes using a table. Look for errors in the y column. Let me go ahead and keep scrolling up in the x column for a while. In other words, I'm going to make x get smaller and smaller and smaller, more and more negative. What you may be noticing is that y value is getting closer and closer to a certain number. And the value that that x is getting closer and closer to is -1. It's our horizontal asymptote. Now, it's never going to get there completely. In fact, if you're bored, if you want to hold down that up arrow, like I'm kind of doing, and keep scrolling smaller and smaller and smaller, you'll see that you're never going to quite get to -1, although the graph is getting closer and closer to it. So that could be one way, a very I think, annoying way, but a way to find a horizontal asymptote. Scroll through your x's and see what y is getting closer and closer to.